This video is talking about deadlock and resolution techniques of deadlock using suspend and resume methods. Let's look at what is deadlock. A deadlock is a special type of error, or we can say it's a situation where two threads have a circular dependency on a pair of synchronized objects. Means that let's say there are two threads like T1 and T2. Both T1 and T2 are holding two different objects. These two threads are trying to access the synchronized methods available in other threads. Let's say T1 is trying to access a synchronized method there in T2. At the same time, T2 is trying to access a synchronized method there in T1. This is what we call a deadlock, right? Here, these two threads may not finish their task because these two threads are waiting for the other resource which is already there in a monitor, right? Let me create a simple program where it talks about deadlock. Yeah, let's say I have a class called A and of course class B, and then the implementation program, let's say demo yeah. In class A I have something called void call off or void for of B space B. Of course it's a synchronized method. Yeah, and I have one more synchronized method called last of. Within this I am going to print inside A, and here I am going to put this thread for 1000 milliseconds in waiting state. Yeah, now thread is in a waiting state. Thread dot sleep of 1000 milliseconds, and yeah, and after that it try to access B dot last of method, and of course the same code or the same methods are there even in the class B. Let me copy this, and of course the same methods are available in class B also. In class B, this method requires object of A and it invoke the last method there in class A. Here it is in class inside class B. That's it. Yeah. Here class A and class B are two different classes. These two classes are going to handled by two different threads. Okay, so these two different threads are trying to access the resources. Now A space A equal to new B space B equal to new B off. Now in the constructor demo deadlock off, in the constructor we are going to create threads. So of course it extends thread class, or we can say implements runnable interface. Within the constructor we are actually creating a thread, racing thread. Here one thread is actually running this program. That thread we call it as a main thread, right? Apart from that, we do have one more thread we created, that is T, where T is a racing thread or a child thread. Okay, T dot start off is actually invoking runoff method, public void runoff. Here this runoff method is actually trying to access b dot, what is the method name? In B we have a method called far, b dot far of a, and of course main thread is trying to access a dot far of b. So here I have two threads. One thread is running this program, that is main thread. Main thread is actually call the method called far off, and at the same time child thread or racing thread is created, and this invokes runoff method. In this we invoke far off method, which is available in class B. So this time these two threads are in a waiting state. Okay, main thread as well as racing thread both are in waiting state. So after 1000 milliseconds these threads come out and trying to access a synchronized method which is available in the other class. Main thread is trying to access far off method by passing b. Here the main thread is trying to access b dot last. B dot last is the method, synchronized method monitored by a racing thread. Okay, so it won't reveal the resource, no, so it won't get execute because this last method is a synchronized method and monitored by racing thread or child thread. In the same way, b dot far off a is actually being executed by racing thread. So in the class B we invoke this particular part, we come out of this waiting state, and then we call last of method there in class B. This time this last of method is actually a synchronized method and monitored by main thread, right? So once it is executed by main thread, it won't reveal the resource. Now deadlock occur. So when you run this program, you don't get any output. Let me run this public void main, public static void main string args of. Within this we are going to create new demo deadlock of. Yeah, so once you run the program, it creates the object of demo deadlock. That time we created the object of class A, class B, the constructor got invoked, so a racing thread is created. Of course main thread is being executed. Main thread invokes class A object, and racing thread invokes child class B object for method. So both goes to the waiting state for 1000 milliseconds. After that they come out and trying to access the synchronized method. Let me run this program. Java space demo deadlock. Yeah, it won't give any results. So main thread is waiting for child thread method or racing thread method, that is last of, as well as racing thread method last of, racing thread method trying to access last of method there in main thread. This is how deadlock created, right? So to come out of the deadlock, we have to control C, we have to issue control C. Yeah, so this is how we created a deadlock. In fact, to resolve the deadlock, we do use suspend and resume. When you issue suspend command, suspend method, probably that particular thread goes to waiting state forever. You have to invoke or you have to get that thread back to running state by calling resume of method. So to demonstrate the suspend and resume methods, let me write a simple program where these particular methods helps you in resolving the deadlock. Okay, let me write a simple program on this class demo or suspend thread suspend demo extends thread class, yeah, and class demo, we'll write this first, yeah, demo of, it requires a message string msg. In the constructor we are going to create a thread object, new thread of this comma msg, okay, and then this dot msg equal to msg, where msg is this string object which is a instance variable. Thread is also an instance variable, yeah. So we created. Now t dot start off, and then it invokes run off method, public void run off. Here I am going to print first 10 natural numbers for int I equal to 0, I less than 10, I plus plus, yeah. So we have to put it in a try block, try, catch exception space e. Within this system dot out dot println of msg plus I, yeah. And after printing each natural number, I want to keep this thread in a waiting state about 200 milliseconds, right? Yeah. Now I am going to write the main method, class demo suspend suspend and resume, public static void main string args of. Here we are going to create the object of, yeah, sus demo, sus demo space s1 equal to new sus demo of 1, like that, s2 of 2, right? So the moment when I create s1, automatically those are in action. They create a thread, and then the thread is actually invoking start off method. Start off method actually invoke the run off method, inside which we are trying to print 0 to 10 by keeping that thread in 200 milliseconds in waiting state, right? Now here I am going to do this thread dot or s1 dot in try block. Yeah, in try block we are actually doing s1 dot t dot suspend off. Yeah, before that let me write system.out.println of suspended. Thread 1 is suspended. So thread dot sleep off, not required. Thread dot sleep off 1000, and then s1 dot t dot, let's say resume off, and this time we write restarted, started again. S2 dot T dot suspend off, and then thread 2 is suspended, and S2 dot T dot resume off. After suspend, I want to keep that thread in waiting state for 1000 milliseconds. Then I just printed thread 2 is resumed or restarted again. Yeah. So let me run this program. Yeah, we have to issue the. So we got the errors, warnings, we don't care about it. Just run the program demo SR. Thread 1 is suspended initially, right? Later on, thread 2 only printing 0 to 4 somewhere. After that, thread 1 come back and started again 0, 1, 2, 3, 4 like that. By the time thread 2 is suspended, finally if you see both threads are working, that time 1 is printing 5, 2 is printing 6, 1 print 6, 2 print 7 like that. Alternatively or simultaneously these two threads are working on the same function or a same method. This is how suspend and resume methods works. Like that you can call stop off, right? So using this you can resolve the deadlock also, where and when you find a deadlock you can suspend one particular thread such that that resource is being accessed by other thread and there is no chance of occurring, or there is no thread, there is no deadlock.